Hey guys, Dr. Brown here with Kubo Math coming to you from Tarlac City, Philippines. And tonight this is Calculus 1, looking at the chain rule and the general power rule. We've looked at the simplified power rule earlier, so now it's going to get a little bit more complex, especially the first time you ever see the chain rule. Your hair will catch on fire and you'll, wow, what is this? Okay, that's what happened to me the first time I saw it. Maybe it's okay for you. But I'm going to give you a much simpler overview of this than I think I've received. Let's say you have, let's look at a function we had in the past. Let's say we had x squared plus 2x, and that's f of x. And we're going to take the derivative of that. Okay, so f prime of x. We would say bring the 2 down, x to the 2 minus 1, so that's 1, 2x. And the derivative of 2x is just 2. So that's x to the first, bring it down, 1 times 2. Then x to the 1 minus 1 is x to the 0. So we end up with 2x plus 2. Okay, no big deal. All right. What if, though, we had that function and we did that? Now how do you take the derivative? So let's assume for a moment that I have some function like we had in parentheses. We'll call that, well, just say it's on the inside. Then I perform some other function on that. And we'll just call this h of x. And I want to take the derivative of that. So now I have some function of x that another function is performing a function on. So if I want to take the derivative of that, h prime of x, that equals the derivative of what's on the outside. So derivative dx of what's on the outside times the derivative with respect to x of what's on the inside. I told you your hair would catch on fire. You know, we just haven't performed functions like that in the past, or taken derivatives of functions like that. So if you think about inside and outside, if you want to take the derivative of a function, take the derivative of the outside and times the derivative of the inside. Okay? Now, we usually call that g of x, and then f of g of x. So this would be f prime of g of x times the derivative of g of x. Now your hair is full flame. All right, let's do a simple example. Let's say we're back to that x squared plus, we'll just say x squared plus 1 cubed. We'll just let h of x equal that. Now this is where the general power rule comes in. In the past, let's say we'll call all this u. U be inside, okay? U are in here. But really, it's u of x, right? U is now a function of x, but I'm going to leave that off. But we'll just know it's u of x because u equals x squared plus 1. If we said, well, let's take the derivative of u, well, it would be du, that's sloppy, isn't it? Du equals 2x. So that derivative. Now then, let's substitute u in here. So now we have h of x equals u to the third power. Let's take the derivative of that, h prime of x. Oh, now we can just do the power rule as we've always done, with one exception. Well, let's go ahead and bring the 3 down. 3u to the 3 minus 1. Oh, that was the outside. Now I have to multiply it by the derivative of the inside. So what's the derivative of u? Obviously it's du. That was the general power rule and the chain rule working together. So now, since we're in the u world, we need to go back to the x world. We have 3u, which was x to the second power plus 1, raised to the second power, times du, which was 2x. So 2x times 3 gives me, well, let's get up here where we can see 6x, and then x to the second power plus 1 squared. That would be h prime of x. Chain rule and general power rule working together. How cool is that? It gives us a whole new dimension to solving problems. Work with the outside and then work with the inside. All right, so now we have f of x. Well, it's just, I'm going to call it y so I don't confuse us. Y equals 3x minus 2x squared cubed. It's very similar to what we just did. Let's make it simple. Let's call u equals 3x minus 2x squared. Du equals 3 minus 4x. 2 times 2, x to the 2 minus 1. Okay, 3x to the first, 1 times 3 is 3, x to the 1 minus 1 is x to the 0, and that's 1. 1 times 3 is 3. Now then, we have y equals u cubed, similar to what we had before. Y prime, now keep in mind, u is a function of x now. So I have to perform the general power rule, 3u to the second power, times du, because I have to now do the outside derivative and then look inside and do the derivative on the inside. So we're in the u world. Let's go back to the x world. 3 times 3x minus 2x to the second power times du, which is 3 minus 4x. Now, if we wanted to, we could multiply the 3 in here. That would be 9 minus 12x times 3x minus 2x squared. Oh, I left my second power off, didn't I? Oh, hopefully you were screaming into the monitor. Wow, he missed it. Whew, man, that was close. Okay, this was inside, this was the function outside. G of x, f of x. We set g of x equal to u. U be inside. U to the third power, that was our function. Take the derivative, 3u to the second power du, and that was our du. We go from the u world back to the x world. Clear as mud? Hey, let's keep working them. It gets better. I think, for me, when you get a new tool in the toolbox, it just expands your mind just a little bit more, which is very important in life. Keep learning, keep learning. Keep challenging yourself. It's just good stuff. All right, I better check these off or I'll work the same problem again. Okay, we have, let's say y equals this guy here, the third root, that's a 3, of x to the second power minus 1 squared. Oh, well, let's rewrite that. X to the second power minus 1 squared to the third. Oh, to the 1/3, sorry. That's the cube root, so it's to the 1/3 power. We can rewrite that. Remember, a to the m raised to the n, remember the rule, is a to the m times n. Okay, that means I've got x to the second power minus 1 to 2 times 1/3, which is 2 over 3. Okay. Now then, let's take the derivative of that. Y prime, and let's get it over here where we can see it a little bit better. Y equals x to the second power minus 1 to the 2/3. Well, let's let u equal x to the second power minus 1. du equals 2x. When you get to implicit differentiation, you'll say 2x dx. You'll take the derivative of that thing. Because anyway, I don't want to confuse you there, but it keeps expanding. Just say that. As we keep learning, we'll keep challenging ourselves in new ways. Okay, so let's substitute u be inside. Y equals u to the 2/3. U prime equals, bring the 2/3 down, u to the 2/3 minus 1, which is 3/3, okay, du. Okay, so now we have 2/3 u to the minus 1/3 du, which was 2x. So now we have 4x over 3, u, which was x squared minus 1, but it's to the negative 1/3, so I'm going to go ahead and put it in the denominator, which would be x squared minus 1 to the 1/3. Okay? Everybody okay there? Chain rule as well as the general power rule. All right. All right, we have now minus 7 over 2x minus 3 to the second power. So y equals minus 7, 2x minus 3 raised to the second power. Well, let's rewrite that. Y equals minus 7 times 2x minus 3 to the negative 2. So y prime equals minus 7. I can use the general power or the constant multiple rule. Pull the 7 out, and now I'm just going to take the derivative of this guy. Well, let's let u equal 2x minus 3. du equals 2. So derivative of 2x is 2. Derivative of a constant 0. So that's just 2. Okay. So now I have u to the minus 2. And I want to take the derivative of that. So if I take u prime equals minus 7 times minus 2, bring the negative 2 down, u to the minus 2 minus 1 is minus 3 du. Okay, so I have negatives times negatives a positive, so that's a positive 14. U, which was 2x minus 3 to the negative 3 du, which is 2. So this gives me 28, and I'm going to pull the negative to the negative 3 down to the denominator, 2x minus 3 to the positive is cubed. So constant multiple rule. Just took the derivative here, did the u substitution, found du, and worked through it. Now, you really don't have to do that. You could just say -2 times this. So you could have just said, okay, I'm taking the derivative of 2x minus 3 to the -2. I take that -2, put it in the front. So that's -2 times 2x minus 3 to the -2 minus 1 times what's inside, which is 2. Derivative of that would be 2. So you could have went about it in that manner. And you would have had the exact same thing. But early on, it's a little bit simpler when you can to just find a UB inside, and then it just makes it look simple. And then you can substitute back in the complicated piece. However, not all of them work that way. Like this next one, for example. Okay, let's see, that was here. All right, so now we have y equals, well, okay, this one's, yeah, you can't do a u substitution for this one. Oh, remember the product rule? Now we're trying to take the derivative of this guy. Let me rewrite that. Well, I'll rewrite it here. That's x squared times 1 minus x squared to the 1/2. Okay, y prime, remember, was the first one times the derivative of the second one. Well, let's put him over here. 1 minus x to the second power. Well, you could do this here. I'm pulling this off to the side. I'm going to let u equal 1 minus x squared. du equals minus 2x. Okay? So now what do I have? I have u to the 1/2. And I'm taking the derivative of that. Let's say h equals u to the 1/2. h prime of x equals 1/2 u to the minus 1/2 du. So now I would have 1/2 u, which is 1 minus x to the second power, to the minus 1/2 du, which is minus 2x. And of course you could simplify that. Minus 2x over 1/2 gives you minus x, 1 minus x to the second power to the minus 1/2. Let's see, let me go back up here and see if this is what I end up with. Of course that would be just for this piece. That's the first one times the derivative of the second one. So the derivative 1/2 times 1 minus x squared to the minus 1/2, so that was 1/2 minus 2 over 2, gives me this, times the derivative of what's on the inside, which is minus 2x. Okay, plus, that's the first one times the derivative of the second one, plus the second one, 1 minus x to the second power to the 1/2, times the derivative of the first, which was 2x. Now then, what do I have? All right, I have minus 2x over 1/2, which is minus x, times x squared gives me minus x cubed, times 1 minus x squared to the minus 1/2, okay, plus 2x, I'll pull this to the front, times 1 minus x to the second power to the 1/2. Okay, I've got a negative x cubed over, I'm going to pull this to the bottom, 1 minus x squared to the 1/2, because I pulled it down, plus 2x times 1 minus x to the second power to the 1/2. Now if I wanted to, we could say I need to get a common denominator here. So to do that, since I have nothing underneath on this one, nothing underneath, let me multiply it by 1 minus x to the second power to the 1/2 over 1 minus x to the second power to the 1/2. And that would give me then both of these, 1 minus x to the second power to the 1/2. So they both have the same common denominator, which is minus x cubed. And you'll notice, well, let me put 2x down. You'll notice 1 minus x to the second power to the 1/2 times the same thing. Now I have a to the 1/2, a to the m times a to the n, and it's a to the m plus n. So 1/2 plus 1/2 gives me 1. So I just have 1 minus x to the second power times 2x. So we can reduce that. So this is why I like whale blubber. The more I chew it, the bigger it gets. So minus x cubed plus 2x times 1 is 2x. 2x times minus x squared is minus 2x cubed. Minus 2x cubed all over 1 minus x to the second power to the 1/2. So minus 1, okay, so minus 2x cubed. So I've got minus 3x cubed. Let me go over here. Minus 3x cubed plus 2x over 1 minus x squared to the 1/2. Wow. That's a lot there. Of course, you could factor the x out, but we'll leave it like that. So this would be the answer for the derivative of that function where we had to use the chain rule and the general power rule to get the derivative. Hopefully I didn't screw that up somewhere. If I did, you should text me. However, I do cheat a little bit. I have the answers over here just in case I do mess up. I should know that and then make the correction. It is hot and humid here today. Let me wipe up my board a little bit. Hopefully everybody's had a great day and you're studying your math. Yes. Study, study, study. Expand your mind. Okay. This one is going to be crazy. All right, so y equals x divided by the cube root of x squared plus 4. Oh. Now, I would bring it into the numerator and do the product rule is how I would probably do this. But I'm not. We're going to use the quotient rule just because we need to use a quotient rule to have an experience here. This would be x divided by x to the second power plus 4 to the 1/3 because it's the cube root. And you can already see I would bring this up and have a negative 1/3 just through the product rule. But we're not going to do that. We're going to venture out here and go for it. Okay, so what do we have? We have quotient rule. Remember, we have, if we have f of x over g of x, we have the bottom one times the derivative of the top one minus the top one times the derivative of the bottom one all over the bottom one squared. You can see the fun is about to start. Wahoo! Okay. And always remember, put the bottom one down first. Okay, if I take this number and square it, I have a to the m raised to the n. And that's a to the m times n. We used that earlier. If I take that number and square it, which is what, it was g of x squared in the bottom, I have x to the second power plus 4. So 1/3 raised to the second power is 1/3 times 2, which is 2/3. So I'll go ahead and just write this as the 2/3 power. Now then, I have the second one, which is x squared plus 4 to the 1/3 times the derivative of the top one minus the top one times the derivative of the bottom one. Whoa, okay. 1/3. Bring the 1/3 down. That's 1/3 times x squared plus 4. And 1/3 minus 3/3 is minus 2/3 times the derivative of what's on the inside, which is 2x. 2x. Derivative of a constant, 0. Ooh, okay, let me separate these out. This half and that half, because once I bring this negative 2/3 to the bottom, in order to get a common factor, I'm going to have to do some multiplication here. So x to the second power plus 4 to the 1/3 times 1, okay, over x to the second power plus 4 to the 2/3 minus, we've got 2x times x is 2x squared over 3. I'm going to leave that in the numerator for now. And that's divided by this, x squared plus 4 to the 2/3. I'm going to go ahead and bring this one to the denominator, and that's x squared plus 4 to the 2/3. Oh, okay. If I multiply these two together, well, now a to the m times a to the n is a to the m plus n. So what is 2/3 plus 2/3? That equals 4/3. So I'm going to erase one of these just to save some space. That is really that to the 4/3. Okay, now then, you can see in order to get this denominator to be the same as that denominator, so I can add those fractions, I need to multiply this side by 1, but I want that 1 to be x to the second power plus 4 to the 2/3 over x to the second power plus 4 to the 2/3. And that would give me, again, a to the m times a to the n, m plus n. So 2/3 plus 2/3 gives me the same value. So let's put all of that over x to the second power plus 4 to the 4/3. Now, let's go back here. 2/3, or a to the 2/3 times a to the 1/3 is a to the 2/3 plus 1/3, which is 1. So it gives me 3/3. So I end up with that fraction just to the first power. So I end up with x squared plus 4, all in parentheses, to the first power, which is just x squared plus 4, minus 2x squared over 3. Okay, I can get a common denominator up top by multiplying, let's put all of this up top over 3 over x to the second power plus 4 to the 4/3. So this would be 3x to the second power plus 3 times 4 is 12 minus 2x squared over 3. I'm running out of room here. Can you see on the other side of that? So that would give me 3x squared minus x squared is x squared plus 12. And I'm going to now move my 3 to the bottom. 3 times x squared plus 4 to the 4/3, raised to the 4/3 power. Whew. Okay, that was a quotient rule, chain rule, general power rule, and some cool algebra, okay? And we made it, and we got the right answer. Wow. Lucky us. Okay, I do write them down just in case I mess up, so that and I'm human, I do mess up, and a lot. But I need, that way I could go back and fix it, and you could see the error and the correct solution. Okay. Now let's move on to some trig functions. Oh, all right. You probably hear me sweating. All right, sine 2x. Let's let y equal sine 2x, and we want to find the derivative of sine 2x. Oh, let's rewrite this and make it sine u. U equals 2x. du equals 2. Okay. Actually, I probably should write these du dx, because you're taking that derivative with respect to x, but I'll leave that off. Okay, so now y prime, the derivative of sine u is cosine u du. Chain rule. Whoa. Okay, that equals cosine 2x times 2. I'll just put the 2 here. 2 cosine 2x. Okay. Actually, there's a multitude of derivatives you need to understand. Derivative of sine x is cosine x. Derivative of cosine x is minus sine x. Derivative of tangent x is secant squared x. Okay, and then you need to learn the derivatives of the inverse sine, inverse cosine, inverse tangent. So secant, cosecant, secant, and then cotangent. And there's derivatives for those. But once you get into integration, if you know the derivative of something, okay, if the derivative of this is cosine, then the integral of cosine would be sine. So I'm taking the derivative of dx of each one of these to give me that. But if I integrate, I go back the other way, and you'll get to that. All right, cosine. Let's let y equal cosine of x minus 1. Okay, let's let u be x minus 1. du, okay, du now is just dx. It's actually just 1. So we end up with the y equals cosine u. Y prime, the derivative of y with respect to x, the derivative of cosine was minus sine x, so minus sine u in this case, du. So it'd be 1, so it's just minus 1 times minus, let me put minus sine, go back to the x world of x minus 1 times 1. Okay. Clear as mud so far. All right, we have y equals tangent 3x. Let's let u equals 3x, du equals 3. Derivative of u with respect to x equals 3. So now y equals tangent u. So y prime equals the derivative of tangent was secant squared. So secant squared u du, which is, if I now go from the u world back to the x world, that equals secant squared of 3x times du, which was 3. So now the derivative of tangent 3x equals 3 secant squared 3x. All right, one more, and then we'll call it a night. This one's, as I mentioned in a previous video, when you look at, like this function, sine cubed of 4x. The nomenclature on how they write this drives me crazy. This really means sine of 4x cubed. That's what that really means. And you'll see me sometimes, well, actually right now, because we're trying to take the derivative of that, and we're going to have to use the general power rule, okay, and then the chain rule to do this. And it's not so obvious, at least to me, that that is this. Anyway, so that's, I have, as you've already seen in some of the videos, I have certain kryptonite that just gets me, okay. All right, so let's let u be sine 4x. Oh. Du, what's the derivative of sine? Is cosine. So now it's cosine 4x times, actually, what would be another, we've let that be u. But let's let this, well, maybe not. I was going to give this another letter because you need to do the chain rule on this. But we'll just say du is cosine 4x times the derivative of that, which is 4. So du equals 4 cosine 4x. Okay, now then, let's go back here. Y equals u to the third power. Y prime, power rule, bring the 3 down, u to the 3 minus 1 times the derivative of what's on the inside. We just did the outside to the derivative of what's on the inside. Now we're in the u world. Let's go back to the x world. 3 to the u squared. So I've got sine squared 4x. I hate that. And you could have written it. Matter of fact, let's do it right now. I'm going to just write it the other way. Sine 4x squared times du, which was 4 cosine 4x. Now I have a 4 times 3, so y prime equals 12 sine 4x. And we'll go ahead and put it in their language, squared, sine squared 4x times cosine 4x. That would be the derivative of sine cubed 4x. Sine 4x cubed, and use the general power rule to take the derivative, you know, u be inside. I guess that sounds funny. U be in there. U be inside. Take, I'm assigning not just the 4x like we did. For example, when we have sine 2x, we said we'll let that be u. In this case, I had that function raised to another power. So I let everything here be u. So I could have, you know, that's a simple equation now to differentiate. bring the 3 down, reduce the power by 1. Hey, I've got that. But with the chain rule, I have to take the derivative of what's on the inside. And that's the only additive to what we've done in the past. So 12 sine squared 4x cosine 4x would be the derivative of sine cubed 4x. This has been a good video. This actually ends the rules, explanation of all the rules. We had 9 of them. So this would be 8 videos, I guess. Well, I probably didn't do a video on derivative of a constant, but we had quite a few. We had the power rule, the sum difference rule, we had the product rule, and the quotient rule, and now the chain rule and general power rule. So I've enjoyed it. It's been good. Hopefully you had an understanding. If not, just comment me and let's start a dialogue. Or if there's problems that you're struggling with, let's take a snapshot, get it to me, or let's figure out how to communicate, and so that you can enhance your learning. So that's all for now. Hey, study your math, study, study, study. Work as many problems as you can get. We used to have to go to the library. Now, I mean, this was before there was an internet. So now you have the internet. But let me challenge you on something. I see so many kids nowadays buried in their phone. I was talking to one recently. He had just finished the differentiation, was going into integration, and I asked him to take the derivative of that. Simple problem. Couldn't do it. But yet I see that person every day looking at their phone. And if they're watching this video, I would challenge you to just put your phone down. I'll tell you a small story. When I started to college, I started just to take an electrical class because I was a diesel mechanic and I worked on transport refrigeration units and trucks and all of that. And I wanted to learn electrical systems for the Thermo King and Carrier transport refrigeration. There was a teacher that convinced me to go to school, but how she convinced me was she said, write down for the next 2 weeks every minute of your day. Every minute. How long you slept, how long you were awake, you went to the supermarket or you ate supper, and I did. I wrote down everything for 2 weeks. And then she Paretoed that out, categorized it, and then looked at how much time was in each one of those buckets. I would encourage you to do that because she told me if I could free 2 hours per day, 2 hours per day of my spare time, then I could go to college. I watched TV at that time 2 hours per day. So, wow, okay. So I stopped watching TV. 4 years later, I had my BS degree in electrical engineering technology. Some years after that, I had a master's in business. Some years after that, I had a PhD in reliability engineering, just from not watching television. Now, I couldn't tell you any TV show, but it didn't matter. I mean, TV versus getting an education, a better job, feeding your family, there's no comparison. Heck with the TV. And actually, my dad was a TV repairman. But I quit watching television. So I would encourage you, make that list and look at it. I think you'll find you've got 6 hours of FaceTime every day on your telephone. Take some of that time and invest it in math. It will bring you huge dividends that phone will never bring you, or whatever you're wasting your time on. Okay, give that a shot. Okay, we're trying to make a better tomorrow and build a better tomorrow. do that together by studying math. Okay, that's all for now. Sorry for the long video and then the fussing at you at the end, but I just want everyone to challenge themselves and be better tomorrow than they are today, and do that by enhancing their life through learning new skills. That's my goal. Have a great evening, and we'll talk to you next time. Thank you.